We're going to talk about dilations really quick.
I can see that a few of you have experienced dilations in your life. Who has experienced dilations? Yeah, where did you experience dilation? Optometrist? Is that the eye doctor? That's a fancy word. Eye doctor, yeah. I've only been to an eye doctor once in my life. Hey, listen. And when you go to the eye doctor, they dilate your eyes, right? What happens to your eyeball? Well, it's really your pupil. Your pupil gets bigger. Now, when it gets bigger, does it change shape? Does it also become a heart-shaped or a star-shaped or a octagon? No. Hey, it keeps the same shape, right? It's just enlarged, and then it will eventually shrink back down. And either way, sit up, please. It's still a circle. Okay? And the center of dilation is the middle. And it grows and shrinks around that center of dilation. Now, my story was going to the eye doctor was when my first year teaching, when I was going off my parents' health insurance and their vision insurance, I was going on to my own vision insurance, and I don't actually pay for vision insurance because I've never had to wear contacts or anything. My mom was like, man, we should probably take you to the eye doctor since you've never been in your life before you go on your own insurance. So I went to the eye doctor the first time and experienced that awful dilation that somebody have to go through. How often do you go to the eye doctor? So it was like a 6-week thing? Every 3 months? You just have to go buy new contacts? Huh. Anyway, so afterwards, I remember I went to the eye doctor on 15th floor and State Street. And I remember leaving, and I was at a red light, and I saw that my phone, the light was blinking, so I missed a text message or a, hey, or a call from me. So I picked up my phone to see, I was at a red light, thank you very much. I was not driving. I picked up my phone to see what I missed, but I couldn't see it. It's the first time in my life I've experienced blurry vision because my eyes are so dilated. So I did that thing my parents do, like take it out and in, trying to find the point of which it was focused, right? Why were you driving? I don't know. I wasn't going to drive. I've never been to the eye doctor before. I know. So anyway. I experienced blurry vision when I wish I ever my eyes are dilated. You guys, dilation can grow larger and it can also shrink smaller, right? So a quick little video. Can you go with the middle light switch over there, please? Yes, please. Everyone listen, please. This is a short clip. Hopefully my sound's all turned up. I think it is. Understanding dilations. In math, dilation refers to... Okay, we're going to have to wait. Some people are not listening. Listen over here. I need the bag on the ground, ladies. On the ground, please. I'm not going to ask you again. Understanding dilations. In math, dilation refers to the process of making a polygon larger or smaller without changing its shape. It's picture day. Kate chooses the package with one photo for her parents, a larger one for her grandparents, and smaller photos for her friends. How can photographers print one photo in different sizes? Dilations. Dilation is where a two-dimensional shape grows or shrinks proportionally from a point called the center of dilation. Here we tripled the original rectangle. And here we divided it in half. In dilations, the dimensions and distances from the center of dilation stay in proportion. The center of dilation can be anywhere in, on, or outside of the shape. Scale factor determines how a shape grows or shrinks. If the scale factor is 3, the dimensions from the center of dilation are multiplied by 3. Different sizes, same proportions, same shape. A coordinate grid can help us see how this works. If the center of dilation is 0, 0, and the scale factor is 3, the horizontal distance from the center of dilation is 3, and the vertical distance is 4. Multiplied by a scale factor of 3, the horizontal difference becomes 9, and the vertical distance becomes 12, stretching the shape 9 units to the right of the center of dilation and 12 units up. Nice portrait, Kate. Grandma and Grandpa are so proud. If the scale factor is 1/2, the original dimensions are multiplied by 1/2. The dimensions of the reduced photo are 1.5 and 2. Different sizes, same proportions, with dilations.
Okay, I have volunteer. Volunteer. Omar. Thanks, Omar. Aww. Okay. Here is our friend Omar. Currently, these pictures are congruent. You can hit the light. Turn it back on, would you? What was the symbol again to show that things are congruent? Equal sign with the tilde. What's the symbol to show that they're similar? It's just the tilde. So congruence figures are both congruent and similar. See the similar side on top? That means they're also similar. They're 1 to 1. Now, watch carefully. In order to keep proportions, how do I have to enlarge or shrink Omar's picture? What would I have to pull? A corner. So my point of dilation is right here. I'm going to hold that point steady. Hey, look over this. There's a center of dilation right there. I'm going to hold that point steady, and I'm going to dilate his picture. It's still similar though, right? Proportional. I can also shrink using dilation. And that point in the corner is called your center of dilation. Notice when we dilate, whoops, when we dilate, are the angles changing? No, but the sides, opposite sides are changing. And you're growing or shrinking by what's called a scale factor. Okay? So, thank you, Omar, for letting us use your picture. Look down here at example 1. Okay, I need all bags, ladies. Brianna, put the bags on the ground, please. Thank you. Okay, example 1. We have a triangle. A prime, B prime, C prime is the dilation. So it's the new triangle. A prime, what is that? Right here. A prime, B prime, C prime. That's the triangle that's been dilated. It'd be great if your eyes were this way. The pre-image is a triangle A, B, C. Scale factor of 3 means everything's been times by 3. The picture actually works. This point A is at x equals 1. Point C is at x equals what? 5. What's the distance from 1 to 5? 4. So this length here is 4. If we are enlarging by a scale factor of 3, the new length should be 3 times as long. So the new length should be how long? 12. 4 times 3 is 12. Let's make sure that actually happened. This B prime is at x equals 3. Where's C prime? X equals 15. So from 3 to 15, what's that length? 15 minus 3 is 12. So the length will in fact triple in length. But it has to be on every side. original triangle. Originally it was 2. So the new triangle should be how tall? 6. Does it actually have a height of 6? Yep. Now the center of dilation was right here at the origin. And the distances, we're not going to figure those out because that would actually take the distance from us. We're more involved. But the distances from that center of dilation have also tripled. Okay, so let's look at number 2. Dilate the triangle with these vertices. We need to put these vertices on the grid. Go to 0, 0, which is the origin, and label it A. Okay, what other point do we need to put on there, AJ? 4, 0. So we go right 1, 2, 3, 4. 0 is be right on the x-axis. Label that B. Okay. C is 4, 3. So we're up 4. We need to come up 3 to C and connect them. That's our original pre-image. Now we're going to dilate it with a scale factor of 2. In order to dilate it, we also need to know what the center of dilation is. Where's the center of dilation? Center at 0, 0. Is that actually on my pre-image? Is it on the original triangle? Yeah. So this one's like Omar's picture. We hold this point right here steady. That point doesn't move. Everything else is going to expand and contract from that point. Okay? It's really nice when that point is on your actual pre-image. It's a little more tricky when it's not. Okay, so with scale factor of 2, this side length used to be how long at the base of the triangle? 4. So we have a scale factor of 2. The new image should be how long? 8. And it doesn't shift at all because, other than it just being longer, 5, 6, 7, 8, because our center of dilation, this would be B prime at 8. Our center of dilation was on the picture. It's just going to increase to 8. Point C was straight up above it. Originally was 3 units tall. Because we times the 2 and come all the way up to 6. 1, 2, 3, 4, 5, 6. So 6 is right here. And that will be C prime. And A, is A going to move? No, because we just hold that point constant and we pull it out. And A stays the same. And we could do the distance formula from here to here and find that the hypotenuse there actually doubled in size as well. Okay? We're not treating over yet. I'm going to look at the area. The scale factor was 2. What's the area formula for a triangle? Remember that. Area formula of a triangle? Okay, we remember the area formula of a triangle? Christian? That's volume of a prism. Yep. 1/2 base times height, or base times height divided by 2. Okay? So if we look at the area of the original, let's see how big the original one was. This triangle right here. 1/2 base times height. The base and height always have to be perpendicular to each other. Can you give me fingers in the air, please? What is the base of this original triangle? Want to count? What's the base of the original triangle? Good. So 1/2 times 4. Fingers in the air, what's the height of the original triangle? How tall is that? That's already written too. 3. So 4 times 3 is 12 divided by 2 tells you area is 6 units squared. What do you think the area of the new triangle is going to be, since we have a scale factor of 2 and we doubled all the lengths? 12? Okay, let's find the area of the dilated image. It's a little D for dilated. we need to know the base and the height of the dilated image. Okay, figure from the air, what's the base of our new triangle, which is larger? It's 8. Good. And the height of the new triangle, do you agree with 1? Is it actually 6? Okay. Tell me what is 8 times 6? Good. Divide by 2. Oh, no. 48 divided by 2. 24 units squared. It didn't equal 12. Why did it not equal 12? Well, what happened instead? Instead of doubling, what happened to the area? It quadrupled. Do you know why? Hey, we're not just doubling one dimension, we're doubling 2 dimensions. So we're doubling the length, the width, and the length, which means we're not just times it by 2, everything's being quadrupled. So this is what happens to the area. We have the scale factor, area. The area of the dilated image would be a scale factor squared times the original area. Well, we'll call it A0 for the original. What is the scale factor of this one? 2, isn't it 2? What is 2 squared? 4. So this one quadrupled the original area. And the scale factor was 3. What's 3 squared? 3 squared means 3 times 3. 9. So the area will get 9 times bigger. The scale factor is 3 if we're tripling the length. Okay, flip it over. New triangle. First we need to put the vertices on the grid. Okay, find point A, which is 1, 1. Or we find point A, 1, 1, and label it A. Okay, now what's point B? What's point B? It's no problem. 4, 1, so we come to the right. 1, 2, 3, 4, up 1. Figure that B. And C is 4, 4, so we're already at 4. We're just going to go up from the x-axis, 1, 2, 3, 4. C, and connect those. That is our original triangle, or our pre-image. What? It's right here. So from the origin, we go 1, 2, 3, 4, up 1. Okay, hold on with this scale factor this time. 3. Which means everything's going to triple in length, but look at our center of dilation. What's our center of dilation? 0, 0. Is that actually on? Is that actually on our triangle? No, it's not on our triangle. So it's as if our triangle is like a rubber band coming out center of dilation, and then we're extending it. So there's going to be some extra movement. We're not pulling the corner of Omar's picture anymore. Okay, so that means the picture is going to move. Here's a really easy way to do it, though. It's not as straightforward as the last one, where you can just do 4 times 2 fully, and 3 times 2, and just extend it out, because it's going to move a little bit. So this is how you figure it out. You take your scale factor, and you times each of the coordinates. So our A prime, 1, comma 1, our scale factor was 3. What's 1 times 3? So our new point is going to be at 3, comma 3. 1 times 3 is 3, and 1 times 3 is 3. So our A is going to be at 1, 2, 3, 1, 2, 3. See, it's totally shifted. A prime. B prime, 4, comma 1. Jeff, what would the new point be for B prime if B is 4, comma 1? You take the scale factor and just times. 4 and 1. 4 times 3 is, 12, comma 3. So we come out to 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 10, 11, 12, comma 3 means you go up 3. That's B prime. Let's actually make sure this length is correct. Count the boxes between those. How many boxes do we have? 1, 2, 3. How many boxes is that? 9. Look at the original. How many boxes was the original? 3. Is 3 times 3 9? Yes, so we have the right length. Okay, then we can find C prime. 4, comma 4, multiply both of those by 3. Okay, so what would our C prime point be? 12, comma 12, yeah? So we're at 12. We go up to 12. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The top of this is the 14. So that's C prime. Let's make sure this length is correct. How many boxes are between B prime and C prime? And was the original 3? The original was 3, right? So 3 times 3 should predict 9. So there's our new one. Okay, it's been dilated. It's shifted because the center of dilation wasn't actually one of the vertices of the original pre-image. Okay, the scale factor was 3. Let's look at the area. The area of the original, we didn't know the base and the height. Can you give me fingers in the air? What's the base of the original triangle? I think so. Everyone else, what's the base of the original? Real, come on, count. 1. How much, Real? 3. Okay, and how high is the original? Also 3. 3 times 3 is 9, divided by 2 is what? Not 1/2. Did you say 4.5? Okay, 4.5 units squared. So if we use our scale factor trick, we should know the area of the new triangle. For the area of the dilated image, we take our scale factor squared and times that by 4.5. What is the scale factor, Hobby? What's our scale factor in this problem? Scale factor 3. And what is 3 squared? 9. So we're going to do 9 times 4.5. So we'll figure that out for me, please. What's 9 times 4.5? 40.5 units squared. Okay? To test me, make sure it's right, which it should be. What's the base of the new triangle? From there to there. 9. And the height? 9 divided by 2. 81 divided by 2. Is that going to be 40.5? Yeah. Yeah, it is. Okay. So this time the area didn't triple. How many times larger did it grow? Our scale factor was 3. It didn't triple. What's 3 squared? 9. It grew 9 times larger. So we can fit 9 of these triangles inside the new one. Okay, last problem. This is a polygon now. A parallelogram. With vertices negative 4, 4. Negative 4 from there down. Oh, positive 4. 1, 2, 3, 4. That's point A. Smaller, what's point B? Example for point B. What? 6, 6. So 1, 2, 3, 4, 5, 6 up 6. Yep, point B. Put it on your paper too, please. Jasmine, what's point C? 6, negative 2. Q. And Chris, point D? Negative 4, negative 4. And connect those, we have a parallelogram. Okay? This time our scale factor is not an integer. What's the scale factor this time? Read the problem. What's the scale factor? 1/2. So should a dilated image get larger? Should it smaller? Okay, so everything's going to be multiplied by 1/2, which is the same thing as dividing by 2. So if A is the point negative 4, comma 4, what's the new point, A prime? Divided by 2. 4 divided by, negative 4 divided by 2 is negative 4 divided by 2 is negative 2, comma 4 divided by 2 is 2. So that's our new point. Find that on the graph. Negative 2 up to 2. And leave it A prime. Okay, AJ, what would the new B prime point be if B is 6, 6? Good. Just divide by 2, we get 3, 3. So there's 3 up 3, B prime. Oh, and the center of dilation, we missed that part, but that was right here, as they legend. Okay, Noah, what's the new C prime point? Yep. 3, negative 1, right there. C prime. And lastly, D. Go, what's D prime? D prime. Divide both of those by 2. Their scale factor is 1/2. Negative 2 and, but they're both negatives. Yeah. Okay, that's D prime. Let's talk about the area really quick. Well, actually, first, let's just make sure this heading's actually decreased by 1/2. How long was A to, I don't know that one, D? How many boxes is that? How many boxes? How many boxes is that? 8. And the new one, A to D, did that actually decrease by 1/2? Yep, it's 4. Okay, you can check out all sides and it all works. Let's look at the area. The area of the original, I want to do the area of the dilated. How much smaller is the area of the dilated? Is it just half the size? How do you find the area of the new dilated image? Take your SF. What's SF? Scale factor. Our scale factor is 1/2. So what do you do with that scale factor? We're changing 2 dimensions. We're changing the widths and the lengths by the scale factor. What's 2 dimensions? Scale factor to the what power? Second power, squared. When you're doing area, you're in 2 dimensions. That's squared. Okay, 1/2 squared is 1 times 1 and 2 times 2, 1/4. So the new image is the dilated image is 75% smaller because it only takes up, stop writing, I don't know why. It only, there you go, now it's ready. So, It only takes up 25%. We can imagine 4 of these green rectangles would fit perfectly inside of the original black. Okay? This green rectangle is 1/4 the size of the original, which means it's shrunk by 75%. It only represents 25% of the original image. Okay, the rest of the time is your work time on, you can work on your similar triangle grid problems or the green packet. The dilation worksheet is not due next time. What is due next time is your similarities word problems. So I might recommend taking that into your first priority. On the dilations worksheet, it's okay if you can't see the numbers. Just number each of them 1, 2, 3, 4, 5 on the axes. Okay, either pull out your similarity word problems worksheet or the green packet I gave you today. The word problems are due next time. We do questions on the dilations and this next time. 21. There are 21 problems.